Today we're going to move on and do some more stuff from chapter 3 in your book. In the previous section, we learned about measures of central tendency, or averages. And in this section, we're going to learn about measures of dispersion. A measure of dispersion, the idea is that you're talking about how spread out something is. You want to know whether everything is packed really close together or whether it's spread out over a big, wide area. Because you can have a little bit different kind of distribution depending on which of those happens. Here are two pictures that show you how that works. Both of these are normal distributions, and they both are centered at the exact same place, but you'll notice one of them is spread out wide, the other one is squashed down so it's much more narrow. They have the same mean, but the dispersion ends up being different. One of them spread out more than the other one is. We're going to talk about several different measures of dispersion, one of which is honestly much more important than the others, but we will learn about, I believe, 4 of them altogether we're going to be dealing with. The first one you already did back in junior high. It's the range. Range just literally tells you how much space a distribution takes up. All you do to get it is you take the biggest number minus the smallest number. That's the range. Sometimes people will confuse that with mid-range that we did with one of the averages where you averaged the top and bottom. Range is just maximum minus minimum. It's really easy to find, but it honestly doesn't tell you a whole lot of information, and it especially doesn't if you've got gaps and outliers, or if you're trying to compare distributions and one of them just has bigger numbers to begin with than the other does. But again, all you do is you look at what's the biggest, what's the smallest, and you subtract. So like in this distribution of very odd-looking people, we would have a range of 77 minus 38, which happens to be 39. I had these numbers, I'm going to subtract 5 minus 1, my range is 4. Again, you just take top minus bottom, that's the range. The second of the measures of dispersion is much more important. The second one is what we call the standard deviation. And you're going to get a printout of the notes for this chapter. When you do, if there's one thing that you want to put a big star by or highlight or make sure that you're aware of, it's the standard deviation. That's the big thing that becomes important in this chapter. It tells you here that standard deviation, essentially what that is the average distance from the mean. So what in the world does that mean? Well, like let's say that I gave a test and there happened to be 30 points possible on this test. Let's say that Eric got back his test and he found that he scored 35. I think you would agree that Eric was 5 points above average. Let's say that Joey got back his test and he scored 33. Well, he's 3 points above average. Let's say Meredith got back her test and it just was not her best test and she ended up scoring 28. I think you would agree that Meredith is 2 points below average. Well, basically what I do to find the standard deviation is, and we of course get interrupted by announcements, but basically what I do to find the standard deviation is I take all those distances people are away from the middle, so like 5 and 3 and 2, and I average all of those distances. And what I find is a typical distance everybody is on average away from the middle. Now, that's not really a good formal definition, and part of the reason it's not is if you've got people both above and below, what really happens is they all average out to 0. That's why what we really do is we average the absolute values of those numbers to find the standard deviation. But if you think about that average distance from the mean, that's basically what standard deviation is going to end up meaning. There are a couple of symbols that we use to stand for standard deviation. Just like when we did the mean, there's a Greek letter and an English letter. The Greek letter, which kind of looks like an O, is actually the lowercase Greek letter sigma, and that would refer to the parameter for the standard deviation of a whole population. S or SX is going to end up standing for the standard deviation of a sample. It's SX that you're going to want to look for on your calculator when we go back and talk about finding these things with a calculator. So again, sigma for the whole population and S or SX for the sample. You can calculate standard deviation through a bunch of rather complicated looking formulas. This happens to be one of them. You do not need to know this formula or use it ever. And that's because this is built into pretty much every calculator. Even a lot of cheap calculators will find things like standard deviation. When you calculate one variable statistics, one of the things you'll notice in the readout is SX. And that is the number you're going to want for standard deviation. So, if I say, what's the standard deviation? You calculate one variable stats, and SX is what you're looking for. Sometimes people will say, well, what about that line right below it that says sigma? Honestly, from your point of view, you're just going to totally ignore that line. What it is an estimate of what would be true for the whole population. But that's just an estimate. The SX is the actual calculated value for the sample. And so since it's the accurate one, that's the one that we use. So SX is standard deviation. Now, I know that right now that's just a number, and it doesn't really make a whole lot of sense as to what it is. Honestly, that doesn't matter. I want you to be able to find that number because it's going to keep coming back to haunt us over and over again as we go through the rest of this year. And again, SX, that's the standard deviation. We're going to be using it for lots of other things as we go into statistics, so you want to make sure that you're aware of how to find it. There are two other statistics that we're going to talk about that you can deal with spread. And I'm going to mention one of them quickly, and again, one of them's a little bit more important with what they are. Third one is what's called the variance. The symbol for variance is either sigma squared or S squared. And if you look at what that symbol is, it tells you literally what the variance is. It's the standard deviation squared. So like if I told you that the standard deviation was 5, the variance is going to be 25. If I told you the standard deviation was 2, the variance is going to be 4. You just take whatever the standard deviation is and you square it. That's the variance. Now, later on in the year, you're going to see some problems where they give you the variance, but what you need to know is the standard deviation. And if you just think about that for a second, if you needed to find the standard deviation, what you would do is take the square root. You literally do the square root. So like if I said the variance was 36, the standard deviation must be 6. Okay? Everybody okay with that, hopefully? The last of the things that we're going to talk about is what's called the coefficient of variation. And of the different things that we're going to be discussing, this one is probably the one that actually is the most useful for really understanding things. What the coefficient of variation does is it takes the idea of spread or dispersion and it makes it into a percentage. You talk about how spread out things are as a percentage of the mean. And because it's a percent, that means that normally it's going to be somewhere between 0 and 100. If you have things that are close to 0, they're packed really tight together. If they're close to 100, they're going to be spread really far apart. And that gives you a little bit more sort of common sense way of telling how spread out things were. It's more than just a number, it's a number that you can put on a scale you're used to comparing, like 1 to 100. What that coefficient of variation is going to do is it lets you compare how spread out things that have completely different means are. Like if I wanted to see how spread out the ACT is compared to how spread out the SAT is. You may or may not know that SAT has scores that are a whole lot higher than ACT, but because of that, they seem like they're more spread out. And if I find the coefficient of variation, it lets me compare those two things on the same scale. On the next couple of screens, I've got two different formulas that are basically just saying the same thing two different ways. Here it says I find the coefficient of variation by taking S over X bar times 100. Here it says that I take sigma over mu times 100. Well, both of those are really telling you the exact same thing. They're just saying you take the standard deviation and you divide by the mean, the average, and then you multiply by 100. All the multiply by 100 is doing is it's just moving the decimal point after you divide. Now remember, I can find the mean. It's the very first thing that I see when I do one variable statistics. And the standard deviation is Sx. So like on the readout screen you have there, if I wanted to find the coefficient of variation, I take 1.4719, I take the numbers that I see there, divided by 3.16 repeating, and I take that answer times 100. And here, what I would say is our coefficient of variation is about 46.5%. That's roughly where we're going to end up with. People will sometimes wonder on all of these statistics, how am I supposed to round the answer? You always want to go to one or two decimal places. So like 46.5 would be a perfectly good answer for this. You don't want to over round, but yeah, it's a little over 46%. That would end up being what we have for the coefficient of variation this time. So again, range, you just take the top minus the bottom. Standard deviation is Sx on your readout, and it's just the average distance your data is from the mean. Variance, you take the standard deviation and you square it. And coefficient of variation, you make it into a percent, and you do that by taking standard deviation divided by the mean squared. So those are the measures of dispersion. They all tell you how spread out things are. And again, this is going to have some problems that accompany it where you're going to need to do those different things.